we will solve the problems on factor of safety, which is a part of the statistical consideration in design, or the problems on tolerances. So here problem statement, the two components A and B are assembled with the overall dimensions of 40 plus minus 0.9 mm as shown in figure P 2.8.16. So you can see the two components A and B are joined, assembled with the overall dimension of 40 plus minus 0.9. The dimensions of component A is 10 plus minus 0.6 mm. So here length of the component A is given 10 plus minus 0.6, that will be the 10.6, or either it will be the 9 point. So the tolerance is given as a 0.6 mm. If the overall dimensions as well as the individual dimensions are normally distributed and natural tolerances is equal to the design tolerances, specify the dimensions of component B. So for this component B, our aim is to find out the dimension, that is nothing but the length of this component B. So that is our aim. So the given data mu dash r will be equal to 40 mm. So that is nothing but the overall dimension or the mean dimensions of the component. Mu dash r is equal to 40 mm. And plus 3 sigma cap r, resultant standard deviation will be given as a plus minus 0.9 mm. So here the resultant standard deviation is also given plus minus 0.9 mm. Then dimensions for the component A is given, that is the mean dimensions for the component A is a 10 mm, and a resultant or the standard deviation for component A, not resultant, that is plus minus 3 sigma cap, is given as a plus minus 0.6 mm. Therefore, mean of the component B will be equal to, that is our aim is to find out the mean mu B. So our aim is to find out the mean of the component B, that is the mu B. So we have a equation mu r is equal to sum of mean of the component A and component B. So the resultant mean will be the sum of component A and component B mean. Means the assembly is made by the combination of the component A and component B. Therefore, mu r is given as a 40 mm. Then mu A is a 10. So putting the value, you will get the mu B here 30 mm. So here we will get the mu B is equal to 30 mm. That is nothing but a mean of the component B. Next is a standard deviation of component B. So plus minus 3 times resultant standard deviation is equal to the plus minus 0.9 mm. So the resultant standard deviation sigma cap r is equal to the 0.3 mm. And for component A, the standard deviation is plus minus 3 sigma cap is equal to plus minus 0.6. Therefore, the standard deviation for component A is 0.2 mm. Now, a resultant standard deviation is always equal to the square root of sum of the squares of the standard deviation of the component A and component B. So we have the value of sigma r, which is a 0.3. Then we have a value of component A standard deviation 0.2. Then we are having the sigma b square, that is our aim. So we have a sigma b square is equal to 0.3 square minus 0.2 square, which is equal to 0.05. Therefore, sigma b cap is equal to, that is nothing but the standard deviation for component B is 0. So the standard deviation for the component B is calculated by using the formula of the resultant standard deviation. So here by putting the value of sigma r and sigma a, we will get the standard deviation for component B equal to 0.2236. Therefore, the dimensions of component B is equal to mu plus minus 3 sigma B cap. Putting the value of mean of the component B and sigma B, you will get mu plus 3 times sigma cap is equal to 30 plus minus 0.6708. So this is the dimensions of the component B. 30 is the length and with the tolerance of 0.6708 mm. Now we will see one more problem. An assembly of three components A, B and C as shown in the figure. The mean dimension of component A, B, C are 20, 10 and 15 mm respectively. All the three components A, B, C have the same standard deviation. The overall dimension and individual dimensions are normally distributed. The natural and design tolerances are equal. Specify the tolerances for the individual component. So here in figure you can see the three components are assembled: component A, component B and component C. Then the length of the component A is 20, length of the component B is 10 and length of the component C is 15. Then overall dimensions are 45 plus minus 0.3. So our aim is to specify the tolerances for these individual component length. So the given data, mean of component A is 20 mm, mean of component B is 10 mm, and mean of component C is 15 mm. Then standard deviation for component A, B and C is equal, therefore is equal to the sigma cap. Then UR is equal to 45, that is nothing but the resultant mean. Then tolerances is a 3 sigma cap, that is a standard deviation plus minus 0.3 mm. Therefore, for individual sigma cap plus minus 3 sigma cap R is equal to 0.3 mm plus minus. Therefore, sigma cap R is equal to 0.1 mm. The resultant standard deviation is given by sigma cap R is equal to square root of sum of standard deviation of the component A, B and C. So the putting the value of standard deviation of component A, B and C, will get, it will be root of 3 sigma cap square. Therefore, sigma cap R is equal to 0.1 and is equal to root 3 sigma cap. Therefore, sigma cap is equal to 0.0577 mm. So sigma A is equal to sigma B is equal to sigma C is equal to sigma cap is equal to 0.0577. Therefore, the tolerances for the component A, B and C are 3 times sigma cap A is equal to 3 times sigma cap B is equal to 3 times sigma cap C will be equal to 0.173 mm. So the dimensions with the tolerances for the components A, B and C are, so length is a 20 mm and tolerance is plus minus 0.173. For component B, length is 10 mm with the tolerance plus minus 0.173. And for component C, length is 15 mm and tolerance is plus minus 0.173 mm. So in this way, we can find out the tolerances for each component for the given length. So here it will be 20 point plus minus 173. Here 10 plus minus 0.173. And for last one, 15 point plus minus 0.173. So this is the distribution or specification of the tolerances for the individual component as per given problem statement. Thank you for watching the problems on tolerances by using the statistical consideration in the design. methods.